Hello. The next application of completing the square will be for solving quadratic equations. And here you will get quite a lot of things to read on your own, but I will go through several of them on my iPad. Let's start. Solving quadratic equations, derivation of the quadratic formula, this you will just read on your own, and problem number 2. So two problems which are very closely related. The one of them is find the coordinates of the vertex of the parabola, this you have seen in the previous video, and the second one, find the x-intercepts for the parabola, for the same parabola, or equivalently solve the quadratic equation ax squared plus bx plus c is equal to 0, because then you will exactly get the x-intercepts, and x-intercepts means the intersection points between the graph of this function here and the x-axis. So we are going to solve quadratic equations. And here is the derivation of the quadratic formula. So here is just regular completing the squares, the square, but on general numbers. So you see we have a, b, and c, but the procedure is exactly as you are used to by now. And you know probably from school that this expression here called delta is a discriminant. And if discriminant is positive, then such an equation has two solutions. And now how to find these solutions? So until now it was just completing the square, and here is new stuff. So what we can do here, we can apply the formula for the difference of two squares. And this is, so this, of course, you can take the square root of delta of this discriminant only if the discriminant is non-negative. And so here you apply the formula for the difference of two squares. Here is one square and here is the second one. So the second one is simply the square root of this expression, right? And here you have application of this formula, so that it's a product of sum and the difference of the elements which are being squared here. And by this you get factorization of this expression, of this second degree polynomial. And here you see clearly that you get two solutions to these equations, and you probably recognize this formula. So 1, 2 stands for two different roots, and you see one root is with plus sign before the square root of delta, and the second one with minus. And from this point, this we have already done before, you get the coordinates of the vertex of the parabola. Here, depending on the sign of A, it can be minimum or maximum in this vertex, right? And what has happened here, and it is here marked by this arrow, you see that in this fraction you don't have a squared in the denominator, and this is because you have to multiply this number by a, and then you have cancellation here. This square disappears. Okay, so now you know that with help of completing the squares and with help of this formula for the difference of two squares, you can both solve such an equation, quadratic equation, and find the vertex of the parabola. So really completing the square is a very, very nice thing to be able to perform. And now the problem, solve the following equations, and you see here these are exactly the same problems which we had already in video number 5, so I even use the notes from video number 5. And here the first one is trivial, right? Here is just x equal to 0. Which is the solution. We don't have to complete the square because it is already perfect square. And here you remember that this kind of roots are called double root. because of this square here. So in a way, x equal to 0 is twice the solution of this equation. Okay, we proceed to the next one, and we know from video 6, was it 6? No, 5, sorry, from video 5, that this equation here, which we have to solve, is equivalent to the equation that x plus 1 all squared is equal to 0. Because you remember, we completed the square, and we know that this expression is equal to x plus 1 all squared. And this is equivalent to that x is equal to minus 1. And here again we have a double root because of the square around x plus 1, right? And x equal to minus 1 just zeros the factor x plus 1. Maybe I will, so here we have double root, I will assign some color, maybe yellow, to the solutions, so we are already done with 2 of them. And now it's time for the next one. In the next one, we have completed the square in the following way. This is x plus 3 all squared plus 1. And we see that this equation has clearly no solution, because this would be equivalent to that x plus 3 all squared is equal to minus 1. But a square of a real number can never be negative. So here we have simply no solutions. No solutions. No solutions in this case. That was kind of easy. And the next one, for this one we also got help in video number 5, where we performed completing the square. So now we can write that this equation is equivalent to, you remember that this left-hand side of this equation is equal to x plus 3 all squared minus 49. But now instead of 49, I can at once write 7 squared. And this must be equal to 0. And you know, I have the difference of 2 squares at the left-hand side. So for this, I remember my formula, which tells me that a squared minus b squared is equal to the product of a minus b and a plus b. And in this case, my a is equal to x plus 3, and my b is equal to 7. And you see, when I apply this formula, then I will factor the left-hand side, and then I will be able to use the zero product property. So first, the difference between x plus 3 and 7 is x plus 3 minus 7, and the sum is x plus 3 plus 7. And this is equivalent to x, 3 minus 7 is minus 4, and 3 plus 7 is 10. And again, zero product property tells us that if a product of 2 numbers is equal to 0, then at least one of these numbers must be equal to 0. So this gives us x1 equal to 4, because 4 zeros the first factor, and x2 is equal to minus 10, because minus 10 zeros the second factor. And we have the solution. And now I'm going back to my slides, and first I will show you a geometrical illustration for the solution of this problem D, and then I will show you solutions of these 2 last problems, which you can read on your own, just to tell you that you do have them. So here we go, geometrical interpretation. Again, here is this completing the square, which you have already seen. And this equation is by this equivalent to the equation x plus 3 all squared is equal to 49. And here I prepared a square for you, a square which has side of length x plus 3. x plus 3, and the area of this square must be equal to 49. So here the illustration is of course only for the positive solution x. You have seen that this equation has two solutions, one positive and one negative. This is obviously just a geometrical illustration for the positive solution. And here, you see here, it is again one more illustration of completing the square. X plus 3 all squared is equal to x squared plus 9 plus 6x, right? And this means that x plus 3 itself must be either equal to 7 or minus 7. So here I show you another method without using the formula for the difference between two squares. Just by telling, okay, if the square of some number is equal to 49, then this number must be 7 or minus 7. And in these cases we get exactly the same solutions as we obtained before. And here indeed this illustration is only for x equal to 4. So you see 4 times 4. And here you get the solutions to the two last equations. Completing the square was already performed before, and here just this last step with application of the formula for the difference of two squares, and we get two solutions, and the same in this case. Until now we have done in video number 5. But here, of course, if I solve the equation, I don't need to bother about factor 4. I just can divide both sides by 4. And I don't need to have this number 4 in my equation anymore. And here you see that there are two solutions, x equal to 2 or x is equal to minus 1/4, because of the zero product property. And the last video of this lecture, this is just a gift from me to you. Here you see how parabolas can look depending on A, B, and C. So here you see what happens if A is positive or negative, and in these cases if B is positive or negative, and so on and so on. So you get all the possible situations and the formula for vertex. Thank you for watching. Bye bye.